For convenience, I've reduced the window size so I can have the packet tracer window side by side with the Word document and work on them at the same time. So in our topology here, we have two routers, router R1 and router R2, connected by a serial cable. This would be a wide area network connection or WAN connection. And then router R1 is also connected to switch S1 and switch S2, which are on two different networks. Switch S2 is on 192.168.11 network, and S1 is 192.168.10 network. So routers separate networks because each interface on a router has a different network on it. So that means that this is a separate LAN from this LAN. So there are two LANs here that router R1 is routing between. And then over here, router R2 is connected to two LANs as well. S4 is 10.1.2 network, and the S3 switch is connected to 10.1.1 network. So we have a total of 4 LANs and a wide area network that we'll be working with here. And some of the links are up and running as shown by the green triangles between the PCs and their respective switches. And the wide area network link, the serial link between R1 and R2, is also up and operational. The name of this packet tracer activity is connect a router to a LAN, and they've given us an addressing table for the 2 routers and the 4 PCs, and the IP addresses and the subnet mask and the various default gateways. And it tells us there's several objectives here: display router information, configure router interfaces, and verify the configuration. And it says in this activity, you will use various show commands to display the current state of the router. You will then use the addressing table to configure the router Ethernet interfaces. So by Ethernet, we know it has to be these two because they're connected to Ethernet switches. This is a serial, not an Ethernet connection. And finally, you will use commands to verify and test your configurations. The routers in this activity are partially configured, as we can see. This link has been addressed and brought up. And some of the configurations are not covered in this course, but they are provided to assist you in using verification commands. So let's get started. Part 1, display router information. Step 1, display interface information on R1. So it says click a device and then click the CLI command line interface tab to access the command line directly. The console password is Cisco. The privileged exec password is class. So the first thing it wants to know is step 1A. Which command displays the statistics for all interfaces configured on a router? And something that you might find helpful is this is the PowerPoint slides, and you can use this to look through to help you if you need to remember commands or as a quick lookup. It's a nice summary of the module. And if I look here on slide 11, I'm seeing here is a command that displays statistics for all interfaces on the device, but it only displays IPv4 addressing config information. And that looks like what it's asking. It's saying what command displays the statistics for all interfaces configured on a router. Well, that command is show interfaces. So that would be the answer for step 1A. Show interfaces will display the statistics for all interfaces configured on a router. So for example, if I go to router R1, and this, by the way, is the router itself. It's a Cisco Model 1941. It has some serial interfaces on it, and it also has some Ethernet interfaces on it. So we'll go to the CLI tab and get the command prompt. The password for the console is Cisco. Okay, so the show interfaces command can be abbreviated to SHO space INT, and it will give statistics for listing paginated. You have to hit the space bar to page through for all the interfaces on the device, and it'll give information such as statistics about transmit and receive load, queues and input and output rates and counter rates on things like collisions, multicast messages, output errors, quite a few statistics. So the show interfaces command on its own will go through each interface on the device. The next question it says is which command would display the information about the serial 000 interface only. So again, we're talking about the same command. So I'm just going to up arrow to recall the command. But then I have to add a specific interface name if I want only one interface name. So I can just type S and E and then tab, and it'll complete the word for me, serial. And then the next thing is to enter in the information 0/0/0, because that's the interface that it's asking for. And that will give us the information only about that interface. So the answer to question B is you could type it all the way out, show interfaces, or just show int serial 000, and I can highlight this over here and then right click and click copy, and then come over here to my paper and just copy it and just do a Control V to paste it. But I've already typed it in. That is the command that will display the information for serial 000. Question C says, enter the command to display the statistics for the serial 000 interface on R1 and answer the following question. What is the IP address configured on R1? That information is, IP stands for Internet Protocol. So where it says Internet address 209.165.200.225/30. Again, you can just highlight it and do the right click copy and paste it in. I've already done that, and make sure that you do include the /30, which is the equivalent of the subnet mask that tells us that 30 bits of the 32 bits that make up the IP address are network bits, and that would mean the remaining 2 would be host bits. So that's the answer for C1. The next thing it asks is, what is the bandwidth on the serial 000 interface? Again, very close to where the IP address was, there is a line where it has the maximum transmission unit of 1500 bytes. Right next to that is the bandwidth. So BW is the abbreviation for bandwidth, and the bandwidth for this is 1544 kilobits. It's a serial connection called a T1, and another way of saying that would be 1.544 megabits per second. But you can, again, just simply copy this and paste it into your document, and just make sure that you do include the entire thing that says K-bits, because it could be megabits, it could be kilobits, so you need to make sure that you get that in there. The next thing it wants us to do is to enter the command to display the statistics for the gigabit Ethernet 0/0 interface and answer the following question. What is the IP address on that one? So to get that information, I'm just going to go up arrow to recall my last command, Control W to wipe past a couple of the words there, and I'm going to type a G and then tab, it'll fill that out for me, and then it's asking for 0/0. What is the IP address on R1? As you notice, it's administratively down, meaning that this has not yet been addressed and enabled. So there is no internet address shown. No one has addressed it yet or enabled it. It does give us an Ethernet address, a layer 2 address, but that's not what it's asking for. It's asking for the IP address. So that means that this would be none configured or something to that effect. There is no IP address on that interface. The next question is, what is the MAC address of the same interface? Well, that's right here. This is the 12 hexadecimal character or 48-bit burned-in address, factory address, Ethernet address, MAC address. All those names mean the same thing. So again, you can just copy that and paste it in. for D2. For D3, it wants to know what is the bandwidth. And by now you know where to find that. It's right here. You don't have to copy the BW, but you need to at least write or copy and paste this part. This is a gigabit Ethernet interface, so it's 1 million kilobits per second is bandwidth, which is the same thing as saying it's 1 billion bits per second. But the main thing is just put down what's on the interface right there. And that takes care of D3. In step 2, it says display a summary list of the interfaces on R1. A. What command displays a brief summary of the current interface's interface status and the IP addresses? So I go back over and look at the Module 10 PowerPoint slides. I can get that information from looking through the commands we learned about in Module 10. Which one displays all interfaces, their IP addresses, and their current status? Well, that would be show IP interface brief or show IPv6 interface brief. In this case, we'll just take the show IP interface brief. And you could actually even copy and paste that from the PowerPoint directly into this document here that we're working on. So that is the answer to 2A, show IP interface brief. The next thing it wants us to do is to enter the command on each router. We've got, remember, 2 routers, R1 and R2, and answer the following questions. Enter the command show IP interface brief, and how many serial interfaces are there on R1 and R2 according to that output. So we already have a session open on R1's console, so we'll say show IP interface brief, or you can abbreviate it, something like this. So how many serial interfaces are there? Well, we see there's serial 000 and serial 001 in the output right there. So R1 has 2. So let's go look at R2 by clicking on it. Enter Cisco to log into the console and show IP interface brief. Abbreviated this way works. And again, let me widen that just a little bit, make it easier to read. And again, on this one we have the 2 serial interfaces as well. And by the way, if you look at the physical view of the device, you can also see on the back, this is a serial module that has the 2, you can see the hardware, the 2 actual interfaces right there on that interface card that's attached to the device. So the answer would be, we had 2 on R1 and 2 on R2. So you could put 2 on each or something to that effect. How many Ethernet interfaces are on each one? So on R2, we see we have 2 gigabit Ethernet interfaces. That's 2 so far. And we have on R1, we still have our output up, so we can just look at that. We have 2 gigabit Ethernet interfaces on R1, but we also have 4 fast Ethernet interfaces, which are 100 megabit per second bandwidth interfaces. So that gives us a total of 4 plus 2 is 6 on R1 and 2 on R2. So you could put something to that effect. 6 on R1, 2 on R2. Are all the Ethernet interfaces on R1 the same? No. As I just mentioned, 2 are the gigabit Ethernet bandwidth and 2 are fast Ethernet interface types. And that brings us to step 3, display the routing table on R1. A asks us what command displays the contents of the routing table. And you can refer back to your PowerPoint slides or to your lesson, and the contents of the IP routing tables that are stored in RAM memory, you can view the contents by show IP route or show IPv6 route. For this, we'll just use the show IP route. That's the IPv4 version of the command. So show IP route is fine for 3A. And then we'll go on to the next page, and it says enter that command on R1. And answer some questions. So on the router R1 console, show IP route would be the command, or you can shorten it like I've done here. And then we're going to look at that and answer the questions coming up under the step 3, number 1. How many connected routes are there using the C code? Well, you can see right now at this point there is one connected route using the code of C, and then it says which route is listed. For that, you can make sure you get the C route, not the L route. That's the local route that goes with it. That's the actual interface address. So this is the answer. What is the route? It's 209.165.200.224/30. Just make sure you get the /30 on there, because that is part of the route telling the actual mask, the subnet mask. Now, it says, how does the router handle a packet destined for a network that is not listed in the routing table? Well, this is something that could answer a couple ways, but we're going to talk about this specific router when we answer it, because we've learned that if a router has a default gateway configured, a gateway of last resort, if it receives a packet that's not matching any of its routes that it knows about, it'll just simply forward the packet to its default gateway. But as you can see here in this output, the gateway of last resort is not set. Router R1 does not have a default gateway, so it can only route networks that are known about in its table, which is what you see here. And if it doesn't know about the route, what it will do is to drop the packet. If it had a default gateway, as I said, it would forward, but it doesn't. That takes us out of part 1 into part 2, where we're going to do some configuration. So step 1, it wants us to configure the gigabit 0/0 interface on R1, which we can see if we hover over the red triangle there. It tells us that this is the gig 00 interface on this side leading to LAN S1. So we're going to be configuring that interface. And the document's nice enough to give the commands to do this. So first go from exec to privilege exec using the enable command, or EN for short. They've told us the password is class to get access. And next is the configuration mode, which we can go into, shorten to CONF space T. The next is to type the word command interface to put us into interface command mode. You can type IN and hit tab at that point if you want, or just abbreviate. And we're talking about gigabit Ethernet 0/0. Again, G tab will fill that out. 0/0, and then enter. First, we're going to give it an IP address. IP space address. Again, you can do tab completion. And the address that we're configuring is 192.168.10. That's the network portion. And then .1 is the host portion. And then we know this because the mask is 255.255.255.0. And you have to have the subnet mask when you configure the IP version for address. The next thing is that we can not do anything until that interface is enabled, and to activate it is no shutdown, or no shut for short. Once we do that, we'll get feedback from the device that the line is coming up. And the last thing it wants us to do is to give a description so that anyone looking at this knows which interface, which is at the other end, and what is it connecting, by putting a description on it. And the description is, this is the LAN connection to S1. I've copied that in my document. I'm going to paste it on the command lines to save me some typing. And now I've completed what I need to do on that interface. So rather than type exit twice to get back to privileged exec command, just the command end will go all the way out. And it says, now R1 should be able to ping PC1, because the two green triangles tell us this link is now operational. So PC1's IP address is 192.168.10.10 on that same subnet there. So we just use the ping command, which uses the ICMP protocol to determine if that address is reachable, 192.168.10.10. And as we learned about ARP in Module 9, we'll know the first one won't be successful because the router has to ARP to see what MAC address goes with that IP address and wait for that ARP reply to come back. But the remaining 4 ICMP echoes were successful, and so we know that R1 should or is able to reach PC1. So that connection is good. And now it tells us to configure the remaining gigabit Ethernet interfaces on R1 and R2 using the information in the addressing table, and also to remember to activate the interface and configure an appropriate description, including verifying that the configurations are good by doing the ping. So on R1, we have one more interface here that we have to configure, which if we hover our mouse over, we see as gig 0/1. And there's some shortcuts we can do since we've already done some of this work. So we can go back into configuration mode and recall that interface command. Just backspace change 0/0 to 0/1. And then we can up arrow to get our IP address command. And what IP address are we putting on that Ethernet interface is 192.168.11.1. So we just up arrow, change the information that's relevant, and then we bring up that description. We know that this is going to connect us to LAN connection to S2 in this case. And of course, we can't forget to enable it so that it becomes active and starts working, giving us reachability by doing the no shut command. Go out to the exec mode, privileged exec by typing N, and we should be able to ping the PC2, which is 192.168.11.10. So all we have to do is just backspace and change that to an 11. Wait for it to ARP and get an ARP reply back. What is the MAC address that goes with this? And let's see why that's not working. And trying again shows that it is working now. It just took a little longer for the connection to come up, for all the auto negotiation and everything and the ARP to happen. But that connection is good now. It is pinging successfully. So on R2, if you just refer to the address table, Gigabit Ethernet is 0/0 IP 10.1.1.1, and then the /24 subnet mask 255.255.255.0. Our description on this one, it's just the LAN connection to S3, and then of course to activate the interface so that it will become operational and create those routes in the routing table, we do the no shut. And the next one is going to be interface 0/1, so we can just recall our commands, make the changes that we need to. The IP address on this one is going to be 10.1.2.1, so we just need to change that third octet from a 1 to a 2. And then for our description, we only have to change, this is the connection to S4, and of course, enable the interface. Our indicators, our visual indicators are good. We have the green triangles that both links are up, and we should be able to ping PC3 and PC4 from router R2. PC3 is 10.1.1.10. With the ARP, we should be getting some success. Yes, that ping is good. And then PC4, we just need to change that to a 2 there, and it should look pretty good. Yes, okay, so we verified that our configurations are correct and that is working. Step 3 asks us, back up the configurations to non-volatile RAM. On both routers, what command did you use? Well, that would be our copy run inconfig to start up config, or copy run star for short. Just hit return to accept the default value. And so that's COP space RUN space ST will also work. any variation that's unique will be okay for that one. Next, in part 3, verify the configuration. Use verification commands to check your interface configurations. Use the show IP interface brief command on both R1 and R2 to quickly verify that the interfaces are configured with the correct IP address and are active. So how many interfaces on R1 and R2 are configured with IP addresses and in the up and up state? We have on R2, there are 3 2 gigabit Ethernet and 1 serial. And on router 1, we have 3 as well. So that would be 3 on each router for 1A. What part of the interface configuration is not displayed in the command output? So here you see that it shows the IP address, but what other part of that command line when you put the IP address in is not shown? That would be the subnet mask, right? The subnet mask is not shown in the show IP interface brief command. Now it says, what commands can you use to verify this part of the configuration? One thing, we know that the show interfaces command will show what the mask is, and if it shows it as a prefix, as like a /24, that is considered showing the mask. So show interfaces would work for that. Show run, right? That's going to show us what's actually the configuration that was entered. And then there's another command called show IP interface that would work there. Those are some examples of what you could put there. Now it says use the show IP route command on both R1 and R2 to view the current routing tables and answer the following question. So as you can see here, we have a lot more routes than we did before, because every time you put an IP address on an interface and enable it and it comes up successfully, it's going to add the connected route and the local route pair to the routing table for every interface. So B1 asks, how many connected routes using the code C for connected do you see on each router? Well, on router R2, there's 1, 2, 3, and then on router 1, there are 1, 2, 3 as well. The question says on each router, so that would be 3. How many OSPF routes, which use the O code, do you see on each router? I see 2 on router R1 and 2 on router R2, OSPF, so that's the routes they're learning using that dynamic routing protocol to learn about routes that are connected to other routers. So that's on each router, there are 2. The question then says, if the router knows all the routes in the network, then the number of connected routes and dynamically learned routes, OSPF in other words, should equal the total number of LANs and WANs. So how many LANs and WANs are in the topology? As mentioned in the beginning, this is a LAN, this is a LAN, this is a LAN, and this is a LAN. They're basically saying how many different local area networks with unique network numbers. So there are 4 LANs, and then we have 1 WAN here, the serial connection between R1 and R2. That's the wide area network connecting this area from this area. So that gives us a total 4 LANs plus 1 WAN equals 5. That's our number. Question 4, does this number match the number of C and O routes shown in the routing table? Well, we know that we counted that already. 3 C's and 2 O's makes 5. So 5 equals 5. So yes, that is correct. If your answer is no there, then you might need to go back and review the steps in part 2. And another thing you should do at this point is check your percentage complete on your packet tracer. And right here, this little indicator is saying 100%. If at this point yours doesn't say 100%, go look at the assessment items. Look for a red X, and then go, and that'll probably help you pinpoint what you did. Everything is good if you've got that 100% right now. And finally, it says, by now you should be able to ping from any PC to any other PC on the network, and you should be able to ping the active interfaces on the routers. For example, the following tests should be successful. From the command line on PC1, ping PC4, which will test all the way from this end of the network to this end of the network. And then from the command line on a router, say R2, ping another network, say PC2. So if we go over to PC1 desktop, open the command prompt, and PC4 has an IP address of 10.1.2.10. So that should work if everything is working correctly, 10.1.2.10. And yes, it's working beautifully. And then from R2 to ping PC2, PC2 is 192.168.11.10, and yes, that was successful. That pretty much ties everything together, looks good at this point. If you have that 100%, go ahead and do a save as. Save your packet tracer file. Save your Word document with all of your answers in. And at that point, you're done.